Okay, so we're going to start a new unit, and it's called matrices. So what we need to understand is that a matrix is just it's a representation of an equation. Um, so let's start with this for an example. So if I take these coefficients and I put them in an order, so my x's go in this first column, then my y's in the second column. And notice that the sign in front of the coefficient goes with it. So if it's an 18 with a negative in front, I make sure I put in negative 18. So when I line them up this way, all of my coefficients, these are my x's, these are my y's. So x's, y's, and z's. And then at the end, you'll see it either drawn with a line or 3 dots. These are my answers. Okay, so this is now it's turned into a matrix. Okay, so this is now a matrix, and when we talk about the size, these are rows that go this way and columns that go up and down. So we say this is a 3 by 4 matrix because it has 3 rows by 4 columns. So when we talk about the size or the order, this is what we're talking about. We're saying how many rows does it have, how many columns does it have. So when you have your test or some assignment and it says determine the size or the order of the matrix, this is what we're after. How many rows by how many columns? So when we take it from our system of equations to a matrix, we call that an augmented matrix. So that's taking it from our system of equations and making it into a matrix where these are the coefficients. So that's called an augmented matrix. Okay, and so that's what we have there. Now, much like we did with last chapter, if I want to get rid of this x, I'd multiply this whole row by 2. Okay, with matrices, you'll do the same thing. Like I'll multiply this whole row by 2. And we write that like this: 2 times row 1, actually that's row 2. And then I would add that to row 3. And the difference is that now we keep track of where our answer is. Instead of just having our answer scattered all over, we now have our answer go to a specific spot. So I put that answer back in row 3. So for example, if I did what I just showed you right here, I would multiply all of this row by 2. So I'd have 2, 6, 20, 74. And if I added it to the row 3, so I would just write down row 3 as it is. I would have 0, 1, 2, 74 minus 66 is 8. So now what I would do is I would rewrite my matrix, and the top row would not change. My middle row would not change, but my bottom row is now 0, 1, 2, 8. So we're going to use this process to solve this system of equations. So really what a matrix is it's a way to organize your work, really. Okay, it keeps track of all your answers. You have to put them in nice and neat and orderly, and we'll work with it that way. Just so you know, matrices have come more relevant with computers, especially when they want to code messages, they use matrices. And when they want to use computers have a lot of ones and zeros. And so when we can change this to be ones and zeros, it really makes a huge difference. but just computers in general, because they work with numbers so well. Computers and matrices kind of go hand in hand. And there's a lot of different implementations we can use with them. So I'm going to show you two different ways that we're going to solve systems of equations using matrices. Now, one other thing that I want to talk about before I get started is if I wanted to, this row is not stuck here in the middle. Okay, there's nothing that says I couldn't have rewritten this problem with this at the top. Okay, I haven't changed anything by putting it there. All I've done is just put it at the top, and now I still have my three systems of equations. So with that being said, you can do the same with these. You can swap rows. It doesn't change anything. You're just swapping the places of where they are. Okay, so again, that's an important step that we can use when working with matrices. Now, this is called row echelon form. Row echelon form. And we're actually going to get it to become reduced row echelon form, which is where we get zeros here in these spots as well. The method we're going to make this happen with is called Gauss Jordan elimination. So this process that I'm going to teach you is called Gauss Jordan elimination. Okay. This is also known as the identity matrix because it has all ones down the diagonal. So all ones down the diagonal is the identity matrix with zeros on this side. The reason we like this is if I have it at this point, what this means is I have no x, no y, but z equals 3. Then on this one I have no x, but I have a y, no z. So that means that I have a y equals 4. On this top one I have x equals 5. So that's why we want to make it turn into this form, is because when it's in this form, we know x equals 5, y equals 4, and z equals 3. So there is a lot of work to get it to become this form. Kind of a process that I use to get there. And like I said, I'm going to show you two different ways. Both ways to incorporate this idea. If I can, I'm going to swap rows to get this to become a 1 first. Okay? And then I'm going to combine rows. Most likely, I'm going to combine row 1 with row 2. I'm going to have to multiply this by something. And maybe even this one. I might have to multiply both rows. Okay? So I might have to multiply both rows. And I'm going to combine them to get a new row 2. But when I combine those, I want to make sure that those first terms go away. Okay? Most likely, if I've got this to be a 1 in my first spot, I don't have to multiply row 2 by anything. Okay? If that's a 1, you won't have to do anything more on row 2. And then I'm going to have to do the same thing with row 1. So when I multiply row 1 by a number and combine it with row 2, it does not affect my row 1 that's in here. This row 1 is stuck for a little while, okay? So even though I do work with it out here, so I might have like 3 times row 1, this stuff out here does not change what it is in here. The only thing that's going to change is my answer row, which is going to be row 2. So now I want to get a 0 on my third row. So I'm going to take some number times row 1 and add it to row 3. And I'm going to make a new row 3. So then I'll have those two will be zeros. So the next thing I want to do is I want to get this to become a 0. Okay? Now, in order for that to happen, I'm going to combine this row and this row. Because see how these are zeros? When I add a 0 and a 0 together, those stay as zeros. So in order to get this next step to be a 0 right here, I'm going to take something times row 2 and something times row 3, probably some number, and it's going to make a new row 3. And when I get that, I'm going to have some number right here, okay? So I'm going to divide that row 3 by whatever number I need to make it equal to 1. So row 3 divided by whatever that needs to be to make sure that this is a 1. So that's my 1, 2, 3, fourth step right here. If I'm putting this in steps, this is kind of the order. So this is one method that I'm going to use. Okay. Now the next step I'm going to do is I'm going to get this to become a 0 right here. The way that I do that is I'm going to multiply row 3 by some number and add that to row 2, but now it's going to make a new row 2. Okay, I'm done with row 3 inside of here. And then I'm going to take my number, whatever number is left right here, I need that to become a 1. So I divide it by whatever that number is. And that's going to make my new row 2 again. Okay, so that's my next step. So notice that I've got 0, 0, 1, 0, 1, 0. I need these two to become zeros right here. So the way we make that happen is I again use row 3 and multiply it by some number. Now I add it to row 1 and it's going to make a new row 1. Okay, and that's going to make a 0. And then I am going to multiply, my next step is to get this to become a 0. So I multiply row 2 by some number. That's my I. These are all variables that I'm using. Multiply it by some number, and I add it to row 1, and it's going to make my new row 1. And that's going to give me the 0 in that spot, and then I'll be all done. Okay, and I'll have some number over here, some number over here, and some number over here. Okay, so if you follow those steps, you'll get your answer every time. So there's 1, 2, 3, 4, 5, 6, 7, 8 steps. If you count getting the 1 right here at the beginning, 9 steps. Okay, so it is a lot of steps as to what you're going to do. Okay, so I've gone back to the original problem that I started with. I swapped the row 2 up to row 1, and I've made that an augmented matrix. So I've written down all of the coefficients. It's now an augmented matrix. This is what I want it to look like when we're done. Okay, so over here I wrote my first 3 steps. This is what we're going to do. We're going to take A times row 1, add it to row 2 to make a new row 2. B times row 1 to add it to row 3 to make a new row 3. C times row 2 plus D times row 3 to make a new row 3. So my first step is I'm going to multiply row 1. So this is a 1, that's a 3. I don't want that 3 to disappear. So multiply row 1 by negative 3. I'm going to add that to row 2, and it's going to make a new row 2. So here's what that looks like. Negative 3 times all that's negative 3, negative 9, negative 30. 37 times negative 3 is negative 111. So negative 111. Now row 3 is 3, 7, 22, and 83. So when I combine that, that's 0, negative 2, negative 8, 111, negative, so plus 83 is negative 28. Now I can choose to, anytime you see that they're all multiples of something, I can slip in a step right in here and just divide all of that by 2. By negative 2 if I wanted to. 0, 1, 4, 14. And that's going to be my new row 2. Okay. Now I need to make a new row 3. So I'm going to do that in a different color. I want this negative 2 to disappear, so I'm going to multiply all the top row by 2. So that's going to be 2 times row 1 plus row 3, and it's going to make a new row 3. So that's 2, 6, 20, 74, negative 2, negative 5, negative 18, negative 66. So I have 0, 1, 2, 74 minus 66 is 8. Okay, so if I were to rewrite my matrix, here's where we are right now. 1, 3, 10. Remember the top row didn't change? But my new row 2 is 0, 1, 4, 14. And 0, 1, 2, 8. So this step right here is step C, where we're trying to get this 0. I only have to multiply this by negative 1, or row 2 by negative 1, so we'll do that. Row 2 times negative 1 plus row 3, and it's going to make a new row 3. So I'd have 0, negative 1, negative 4, negative 14. So remember how I said the matrix is really just a way to organize your work? That's all that this is just a way to organize your work. So that's 0, 0, negative 2, negative 6. Again, I see that these are all divisible by negative 2. So I divide it by negative 2. I get 0, 0, 1, 3. Well, that's now my bottom row. 0, 0, 1, 3. This is 0, 1, 4, 14. That's a 14. 1, 3, 10, 37. Okay, so I've now got to here. I now need to get this 0, that to become a 1, that 0, and that 0. So I have 4 more steps still. So I need this 4. Whoops, that was supposed to be a highlighter. So I need this 4. Come on. To become a 1. I mean, not to become a 1, but to become a 0. So I'm going to multiply the bottom row by negative 4. So I'm going to put that right here, because I'm really going to run out of room. I'm going to go negative 4 times row 1 plus row 2, and it's going to make a new row 2. So that's going to be 0, 0, 4, 12. And a lot of you are saying, we just got that to be 0, 0, 1, 3. Remember, this row is not going to change now. I'm making a new row 2, so that row is going to change, not my bottom row in this case. Now I'm going to add it to the middle row, so to row 2. So 0, 1, 4, 14. Now I'm supposed to multiply that by a negative 4. And I wrote that wrong. That's supposed to be row 2 to row 3. Negative 4 times row 3 plus row 2 makes a new row 2. So there's what I did. So now when I add those together, 0 plus 1 is 1, negative 4 plus 4 is 0, negative 12 plus 14 is 2. So this is what I'm looking at now. 0, 0, 1, 3. My bottom row didn't change. 0, 1, 0, 2. So that row is complete. The bottom row is complete. This says that z equals 3, y equals 2. I need to figure out what x is. So I am going to take this, and I'm going to go negative 10 times this bottom row, because I want this 10 on the top row to become a 0. So I'm going to write it right here. Negative 10 times row 3 plus row 1 to make a new row 1. So I have 0, 0, negative 10, negative 30, 1, 3, 10, 37. So that gives me 1, 3, 0, 7. So the only thing I have left that I need to do is I need to get this 3 to become a 0. So I'm going to go negative 3 times row 2, add that to row 1, and it's going to make a new row 1. So negative 3 times row 2, I'm going to write it right there, is 0, negative 3, 0, negative 6. row 1. So now when I add those, I get 1, 0, 0, 1. So my final answer for row 1 is 1, 0, 0, 1. Then my other rows didn't change. So X is 1, Y is 2, Z is 3. That's my final answer. I went through these steps that I talked about on the other page. So all of this, those are the steps that I took. It's a long process. It takes a lot of time. It takes a lot of paper. I'll show you a different way to do it. And it's just a different way of writing it down. Okay, so here's the other way to do this problem. Some like it, some don't. You need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines. You're going to put the first ones in here, 1, 3, 10, 37. Then you're going to skip 3 lines. I can't remember if it's 3 or 2. But anyways, we're going to skip 3. And we're going to put a 0 here. And we're going to skip 2 and put a 0 here. Okay? The reason being is, kind of like the process that I just showed you, we want these to become 0. So here's how that works. So basically we're just doing the work and writing the answer down. So 1 times all, or negative 3 times 1. So we're taking negative 3 times all this, and we're going to combine it to all of this. So negative 3 times 1 is negative 3 plus 3 is my 0. Negative 3 times 3 is negative 9 plus 7 is negative 2. Negative 3 times 10 is negative 30 plus 22 is 8. Negative 3 times 37 is 111. Negative plus 83 is my negative 24. Okay, now I'm going to do this one. I'm going to multiply all this by negative 2, or positive 2. So 2 times x minus 2x is 0. 2 times 3 is 6, minus 5 is 1. 2 times 10 is 20, minus 18 is 2. 2 times 37 is 74, minus 66 is 8. So now these are the next steps on our matrix. Okay, I'm going to divide all of this by 2. So I'm going to make that turn into 0, 1, 4, negative 12, positive 12. And really I should leave space here for that next part. But now here I want this to be a 0, I want this to be a 0. So I'm just going to change all these signs. That has to be a negative 1, negative 4, negative 12. So when I add those, that makes 0. Negative 4 plus 2 is negative 2. Negative 12 and 8 is negative 4. Now I divide all this by 2. 0, 0, 1, 2. So that row is done. Now I want that 4 to disappear, so I'm going to multiply all this by 4. So 0 times, so this row is going to look like this. So now I just need to figure out what I have to do to make that happen. So I multiply this by 4, add it to that. Okay, that goes to 0. Right now that's a negative 1. Multiply this by 4, because that's what I did to this to make that go away. So that's 8. Minus 12 is negative 4. I divide that, and that becomes positive and positive because I divide it by negative 1. So that row is done. Now I want this 10 to disappear. So this row is going to look like this. So I multiply this by negative 10. So that's negative 10, negative 20. I add that to the top row. So that makes that 130. Negative 20 and 37 makes 17. Now this next step, I want that 3 to disappear. So it's going to look like this. So in order for that 3 to disappear, I have to multiply this row all by negative 3. So negative 3 times 1 added to that make it go away. So negative 3 times 4 is negative 12. 17 minus 12 is 5. So somewhere I've messed up along with my math work. I was trying to hurry. So I'll find the mistake and tell you in a moment. But anyways, that gives you the 3 rows that you need. This 4 is supposed to be a 3. So I'll find where I messed up and that'll change this. So I found my mistake. I was hurrying to do this and I did it in my head. 111 negative plus 74 is not 24, it's 28. So anyways, that's where the mistake was made. By hurrying to take this top row and multiply it by 2, you get 2x, 6y, 20z, 74. And that's how I get these blue 1, 2, 8s right here. So now you're going to multiply, you want this to become 0, 0, right? So I'm going to multiply all this by 2 and add it to that one. So that's really going to be 2, 4, and 16. So I add those, that becomes 0. 4 plus negative 8 is negative 4. 16 and negative 28 makes negative 12. Now if you divide all of that by negative 4, you get 0, 0, 1, 3. So that lines up more with what we did the first time. Now I want this negative 8 to be 0, so this can become 0, 0 something, right? So I multiply this row right here by 8. So that becomes 8 and 24. If I add that to up here, that negative 2 doesn't change, but 8 plus negative 8 makes 0. 24 minus 28 makes negative 4. So now I divide all this by negative 2. So that becomes 0, 1, 0, 2. Now on the top row, we want this to become 1, 3, 0. So down here, I have to multiply this by negative 10. So that's negative 10 and negative 30. So negative 10 plus 10 is 0. Negative 30 plus 37 is 7. So on the next row, I want this to become 1, 0, 0. So if I look at the second row right here, if I multiply this by negative 3, that's 0, negative 3, 0, negative 6. When I add that to the top, 0 and 1 is still 1. Negative 3 plus 3 is 0. 0 plus 0 is 0. And negative 6 plus 7 is 1. So those are my 3 answers. So my final matrix is 1, 0, 0, 1, 0, 1, 0, 2, 0, 0, 1, 3. So that was this one, and this one. So again, it's the same process. It's just a different way of organizing your work. And I'll try to do another of these sometime later today and show you. So here's your assignment, page 573, 41 through 44 all, 48 through 55 all. Like I said, I'll make another video and I'll do some of these problems, try to do a couple of them so you can practice watching those and doing them. They are time consuming, not easy, but anyways, that's the notes and the discussion for today.